All right, second part. So it says I can use the area model to demonstrate my knowledge of factoring expressions. So those were the examples that were technically on the bottom of this page for you, but I spaced mine out so I could have more room. So what does that mean for you? You might need to be using scratch paper. So it says a rectangle has an area. Oh, you can't see that. A rectangle has an area of 4x plus 6. If the width is 2, what is the length? All right, let's get it together. So if I think about area, that is the space inside of a shape. So area is space inside of shape. Now I know the formula for area, hopefully you remember the formula for area, is length times width. So this says that you're used to seeing that the area of something is just a number, but this time it's an expression. So I'm going to show you what the area looks like. Yesterday I do realize that there was not much of an illustration, so today I said I'm going to become Picasso and show you my art skills. So it says that this rectangle has an area that has 4 x's. So what does that look like? 1, 2, 3, 4 x's. Put the x's in the middle. Now it says it has also 6. So this side, of course, should be a little longer because 6 is greater than 4. It has these single blocks of 6. So 1, 2, 3, 4, 5, and that's 6. So 1, 2, 3, 4, 5, 6. Now, on this one, the width right now is 1. Because how wide is it? Is 1. The entire inside of it is 4x plus 6. Now I can use those same rules for factoring to find out what is the length. So I know this is the area right now. It says that the width should be 2. Now I'm going to go ahead and factor this first. So I know that the area is going to look like this, 4x plus 6. So I'm going to write the formula on top of it. So A should go on top of that. I got this by doing a length times a width. So it just told me that my width was 2. Alright, so it doesn't matter if I switch this and write width times length. So I'm going to put my width in front. Now I have to figure out what is the length. So what times 2 will give me this expression? So I think, oh, this must be my GCF. That's that number in front of the parentheses that we did. So then I do 4x divided by 2 is 2x. 6 divided by 2 is 3. All right, so this is the width and this is the length. Now, how can I show you what this looks like in an area model that looks very similar to this one, but it's not going to be the same because this width is 1 and the entire area has 4x plus 6. Why? Because this 1 times this expression is still the same expression. But watch me rewrite it to look like what this says. So when you would have answered the question, the answer would have been 2x plus 3. All right. So I'm just going to draw what the model should look like. Or I could just show you on my other paper. So on this paper, I drew out the width is 2. And then the length is 2 x's, which is what we said, plus 1, 2, 3 cubes going across. So now if I find my area, watch this. 1, 2, 3, 4 x's. That was in this original one. Plus 1, 2, 3, 4, 5, 6 single cubes. So this will be like when you see those double boxes on your other examples. This is what that would be. All right, now I'm going to go do number 6. All right, so number 6 says that a rectangle has an area of 9x plus 12. If the width is 3x plus 4, what is the length? So again, I know this is my question, so if I draw this out for you, I would see 9 boxes going this way of x's. 1, 2, 3, 4, 5, 6, 7, 8, x, 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 and x. Double check my numbers, please, and thank you. And then I would see 12 single boxes going this way. Now, this technically is a rectangle, but it's, you know, it looks like a strip. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this whole area, because if I count it, I see 9 x's plus 12 single boxes. Now I think they gave me this time that the width so they said this time that the width was 3x minus 4. Oh, this should be a subtraction. Alright, so I know that the area is 9x minus 12. So I think to myself, alright, if area is length times width, this is my width. What is that number on the outside of the parentheses that's going to give me this area? Now I wrote 2. I didn't mean to do that. So I say, what times 3 will give me 9? I know that that is 3. All right. Now I say, what times 4 will give me 12? That is 3. So this time the length is 3. So then if I check it, 9 times 3x is 9x. 4 times 3 is 12. What joined the expression originally? Subtraction. Now if I redraw this one, it should be, the length should be 3. And then my width should be 3 x's going across. So how does that look? This is my length. Or I could have drawn this in the other way. Bear with me, guys. You can draw it the same way. So this will be 3. This will be 3 x's going across. I got that from here, and I got this from there. So now how many x's do I have in all? I have 9, because 3x times 3 is 9, but 1, 2, 3, 4, 5, 6, 7, 8, 9. 9x. Now it says that the single cubes are going to be 12, but 4 going across. So that's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So therefore I have, oh, no, this should be a 4. So now I have 3x, and then I have a 4. And then that gives me 9x. And then in the original expression I had subtract. 3 times 4 is 12, or you can just count the cubes. So you are going to go do number 5. I'm sorry, not number 5. You're going to go do number 12, which is the one at the bottom of this page. And then you're going to go do number 1, 2, and 3 on your homework sheet. Have any questions? Good luck. This video is a little longer, so good luck. Bye-bye.